Welcome to this stream. We're going to start recording now, and today we're going to talk about a fun issue I've been having with my current PCIe design. So, is the other design open? Let's bring that out. So we're going to talk about two different design choices when doing PCIe. So here is my previous design. I can get it to actually doesn't want. Okay, so here is the previous design. So the previous design uses Xilinx's DMA subsystem for PCIe, but this thing is huge, okay? This thing uses a ton of FPGA resources. I do not like it. It has made my design very crowded and very hard to place and route how I want. But this allows me to have a light bus that accesses all these simple peripherals with a small range. And then it also has a DMA bus, which I can connect to the MIG DDR controller. And it's useful, very useful. But that it's not worked. So I've been trying to figure out a new issue. And my solution to this is what I'm calling a paging in. So we go back to our older design, which uses this thing, which takes up barely any resources. It's great. It's great. I like it a lot. Doesn't have a driver software, but that's okay. We have this little IP that came from Xilinx's answer sheet or something like that. It's been very useful. And so we connect this to the peripheral, so it can connect to all the peripherals. But we have a new peripheral that we call, I can also show you how the debug bridge works today, that we call our AXI extender. And there's a little thing called in page. So what this does is we use dynamic paging. So this allows for the GPIO right here, this little thing, to define the top 16 bits of my 32-bit address spacing. So let me see. Let me check. Is it working? So we're going to program it real quick with this design. Actually, it should be working on it now. We want to here. So we're going to go and program it with that design. That's the design we want. This design right here. So now this opens, programs it. So we're going to have to go back to here, and we're going to remove the device, rescan, and now we'll see the name change. That's the important part here. And okay, that's still working. Let's see if it's actually still working. JTAG targets. Okay, cool. So here is DDR. So let's write a new value to the DDR here. We're just gonna write, classic dead beef. And we can read it again, so there's dead beef there. So we go back to our little page system right here. So we have the extension and the GPIO that's driving the upper page. This GPIO is located at 4007123 here. So these are the restart bits, and this is the GPIO bits. So if we try, and the extender here is at address 40004001000, and let's go ahead and read that. And we can read quite a bit here. So 4001000. If we try to read anything, we won't get anything because there's nothing on that bridge. We get this, there's nothing there. But if we go and we write a proper header to this, right? And I go back down right here. We now read that 64 kilobit range of DDR. And then we can change it. Like if we go where we wrote that top portion right here, we can do like that. And now we will read a different page that will match up to 0860100, like that. So now we can page into DDR, and I don't have to worry about a bunch of things. This will affect the bandwidth, but hopefully we can get something going. So now let's open up a new tab, and we have a program that we used previously to write to this DDR space, but now we have to edit because it's using the DMA from before. So we go, so we have this load bits. I'm going to put some new bits up here. I'll have to rebin them. Okay, let's just get the redo that. I'm not gonna like doing that, but let's go to PyTest and we can just get it writing those existing bit files. So we have a load bits, so we're gonna copy load bits page. Right? Going to open load bits page with plus. And see how easy it was right here? Now we're going to do this page by page by page. I don't like this. I don't like this at all. I might have to do it word by word. So let's hard code this really quick. We're going to do we're just going to do for I in range of we can just do what, do length of b0, right? And we're going to do every 4. Seems like good, right? We're going to print I. And just see if that range works. Loaded, so we're just going to do Python load page. No. So bang bang that sucker. So oh. Did I do that right? Start, stop. Yeah. Well, I guess we could do 0, 4. I guess we could also just, straight up print length b0. Also be okay, cool. Now go ahead and hex that. I'm curious to what comes out. Or how many pages we'll have. So there's 1, 2, 3, 4, 5, 6, 7, 8. Now, what if we do the page? So the page value is that, right? So I'm curious to what that. There we go, since each of our pages. Now if we just do this, let's go. Go ahead. Do that. Go back over here. We want this to be 4, 0, 1. No, we want this to be not that. We want it to be I. Seems appropriate. Okay. Now let's do a memory read of 0, 3, 1, read 100. Yeah, that looks right. So definitely getting there correctly. So how do we want to space this out? Because we want to do that. And then we want to exit. So we're going to do 2 for loops, right? We're going to do for j in the range 4, right? Length db 0. But here we're going to do how did we do byte arrays? So offset is going to be cool. That's where the first one is apparently. 1, 2, 3, 4. Plus j. And j. Seven. Oh, and if I plus j greater than length p greater to or equal to db0, we're going to break. Seems good enough, right? And let's go ahead and just that's interesting. Build. Should return there, right? Anything happens at memory? Nope. So able to do that just fine. Has to be this byte array. So we gotta do an into a byte array, into byte array Python. This is me not knowing my Python. Me not knowing my Python. Okay, let's see how it goes. How do we convert to bytes? The Okay, so let's see if that went through correctly. That went through correctly. So go here. There. 1A is the last one. Oh, see the mistake we made. Okay, cool. I see the mistake we made. Wondering if that would come into play. That should. Okay. Now None of the addresses. Okay. Our M32 design. I change the addressing M32. That one. Okay. Editor. Which one am I looking at? Page address. There. RAM controller. Is the same. Okay, so I think we should be able to open that and be able to study what's going on. Okay, so first we got to create our bins. So to create our bins, show my fault injection off. We're going to create a new folder. And then we're going to go my old little Python file. That's going to be build arrow. All the same, switch bit. So back to here, view2, build bins. So what we're going to do is we're going to open a PowerShell here. Go Python switch bits and we'll go like bits, 1 bits, right? And we want MB PMR B row dot bin. And then we're gonna want to do 1. Do 2. We're ready to go. See, have anything already existing of those? So we're gonna go and drop our bins over here, and then we're going to our where here. So Blaze TMR that what were the base address on the 2 and a 4, I think. Maybe 1. I want to start there. 2. There. Okay, that's good. Load it up. This should have been restarting. Why is that not restarting? Oh, I guess it is continuing. Okay. Next, let's pull up the SDK. See if we can get it working. So once we get this working, So we go to run configuration. We have let's see, run. Okay, seems to be working. Impressive. So you see that address 840. Let's go read 84002 or 84000. So if we go to that location, right? We read 8400123 down 40. These are all the injections we're doing. Already order, but we go up, go to hello world. So it's by 3. Oh, I gotta change the addresses back. It's only sub addresses of it. That's okay. Let's go look back at the sizes. I was kind of curious about the size difference. 135, 175, 184. That's based upon this, right? Four zero, 560, 0. Those two should be similar size. It's kind of interesting for different sizes. Slightly off. Is there a probably just different resources? So let's see. Right. Let's see. LUTA's memory. LUTA's memory is the same. Let's look at the special resources. And the relative, they're like, there must be some special things in here. I also like how the resources utilization is different, even though they're like basically the same design. Okay, so can we go through what's happening here? I guess I'll give you a quick overview of what's happening in the end. So we go back to our diagram, right? So I have a microblaze here, and then I have these things, these DUTs, and I'm loading in partial designs. I have DUT012, and these DUTs are processors like the microblaze that have access to the MIG. And here's the partial regions. We have DUT0, DUT1, DUT2. These are the partial bits that are being loaded in there. And basically what's happening is the main microblaze, this microblaze is using the ICAP right here to do fault injection into these DUTs. And then it repairs them and tests them and stores the data in here, or data in the DDR, and the bits are also, the partial bits are also loaded into the DDR. And that's what we were doing here. We were loading the partial bit streams into the DDR at the specified location. So the main thing we have to do from now is we have to I have to get this working on my 20 FPGAs. And is there anything I need to do to clean up the design? think it's working. The only issue is I need to update. I probably need to copy this whole thing, and I need to update the frames because it should be using. These are all the old frames. 512, 234, 2, 2. And go update those ones. It should be using the previous designs. So, but I'll let this run and see what numbers it gets. Kind of interesting. And then comes the fun, getting this automated. Yeah, I just probably need to make helper functions to do all these reads and writes. Okay, well that seems to be working well. Since there's no one on stream to really ask questions, I think we'll just end it here. Hopefully this helps someone. We do have a single person online. At the moment, does anyone have a question? The one viewer that my thing says I have. Other than that, I think that's probably playing with it. Oh, I guess we could talk about. Let me see. We do have this Microblaze debug bridge that was part of the code I was working on. That was this right here, being able to send messages or be able to get the SDK to work through the PCIe bus. We'll be using this later to load in stream so I can get everything testing and to be able to do the software updates without having to rewrite the flash every time. But I'll have to use what I currently have to reprogram the flashes on everything. Well, thanks for watching. I'll post this on YouTube and I'll show how helpful it'll be. It was kind of mostly my own work, but just some PCIe paging development. Thank you for watching. Good night. Bye.